So here is the ultrasonic sensor, the popular ultrasonic sensor, and like I said, there are better ways to use this HC-SR04. As you can see, the 4 pins here are labeled VCC, trigger, echo, and GND. But having a look at the back, you can see that there are some labelings here. We have if you focus, you see that we have echo TX SDA and trigger RS SEL. So you have some parts for some jumpers, and by shorting one of these two parts, you can change it from the normal pulsing mode to either the I2C or the UART mode, as you can see, R4 or R5. Alright, so now if you look at mine, you will see that I already shorted R5, so it is in UART mode. Now, taking a look at the data sheet, we can see how to use it in UART mode. We have some registers that you must write. If you don't write these registers, you will not get any return or feedback from the sensor. So if we write the register using the values 0 by A0, it will return a packet of 3 bytes, byte H, byte M, and byte L. And from this byte, we can calculate the distance that the sensor has measured. This way, we don't have to measure the distance in our own code. It will measure it by itself and return the values using the UART transmission protocol. So a better view of this datasheet I will show next. So this is a clearer view of the data sheet. As you can see, we have a lot of details here I will be covering. You can just pause to read through. Most of the information down are in Chinese because there's no much resource online, but this was good enough for me to get the information I need to get the UART. Also, you can see that the I2C mode can also be used, but I won't be covering that in this tutorial. Now, if you take a look at this on the screen, you will notice that I use my serial terminal using my OTG serial USB app. You can use it on the Arduino IDE also, but I use it on the serial terminal from the tab. And then by writing the address 0 by A0, you can see that it is returning several values. For example, here at the top, 7A0D78. Well, if you want to check using your serial terminal, you must check using X mode, X. So X mode, you have to check using X mode. And then we'll go next to the code. Now here is a sample code on Esp32. As you can see, I am using the free RTOS task. But let me cover a simpler code. Now you can see that we are using the Esp32. As you can see here, we have the serial hardware serial used, serial 1, and we're using the free RTOS task. We are getting the distance by first writing the address 0 by A0 and then waiting for the serial to release some bytes, which we read, and then we calculate our distance from a particular function. So the function is here below. The function is above here, so you can see float get distance, byte H, byte M, and byte L, and we calculate the values by shifting the values and computing them in millimeters. So this way we do not have to use the pulsing function because the pulsing function is blocking, and if you are using it, my experience with Esp32 is that when you use the pulsing function, it will delay some other functionalities, like your web servers may not function well, and if the distance that you want to read from the sensor is very long, it might delay for about 3 seconds or more, which you don't want. But if you are using the UART terminal, the calculation of distance is done on the sensor itself. All you need to do is to write the register and get the distance and just use it wherever you want. So I believe that this method is far superior to the pulsing function. If you are doing a very simple code, you can use the pulsing function. But if you are doing a code that is multi-versatile, I prefer that you use either the I2C or the UART, which I have explained in this tutorial. If you have questions, you can comment them in the comment section below. I will put a link to this example code so that you can test it on your Esp32 to see that it can run simultaneously without blocking other functions or other code in the sequence. Thank you for watching.